All right. Hi, everyone. I'm Adam Hops with the National Operations Center of Excellence. Thank you so much for joining today's webinar on uh, the LinkerAT tool. We're going to hear from Ed Grasno on the tool and Kelly Claver and Vishali on as well on the project overall. This is part of a 5-part webinar series that's coming out of the Data Integration, Sharing, and Management for Transportation Planning and Traffic Operations. Kelly and Vishali will talk a little bit more about that, but as I mentioned before, please know that other webinars from this this series are on the NOCO website, the NOCO YouTube channel, and then if you go to data.transportationops.org, there's quite a few resources there that all correspond to this project. Thank you so much to Kelly and the team at AEM for planning this webinar series and sharing all these fantastic new tools. We're really appreciative to her and her team over there who led this project. A few housekeeping items. You should all be muted right now. And if you raise your hand during a Q&A, I can unmute you to ask a question, or please feel free to use that chat box down there for any questions, either for our presenters or for me if you have any technical issues. We do have closed captioning and a transcription available. You can go to the bottom of your screen if you're on the desktop app, or top of the screen if you're using the browser to enable closed caption or transcription if that's an assistant anyway. The webinar is being recorded. We'll release it in the next week, and that you can share with others. And post it to the website in our newsletter and YouTube, as I mentioned before. So thank you again for joining us, and I'll turn it over to Kelly.
Thanks, Adam. I'm Kelly Claver. As Adam mentioned, I was the principal investigator for this project. I can't see the slides, Ed, so I'll just let you kind of advance as I speak to the first slides for the presentation. But I'm just going to give just a quick overview of the project. As Adam mentioned, this particular webinar is focused on the LinkerAT tool, and that is really the whole objective of this webinar, is to give you all an overview of the tool and kind of why it was developed, the purpose of it, what it does, and then a little bit of the details about how it works and some of the inputs and outputs. But this is part of a bigger project, NCHRP 08119. The objectives of this project were to look at areas where state DOTs could use guidance or tools or assistance in improving their ability to share, integrate, and manage data for transportation planning and operations use cases. It was a 3-phase project. Phase 1 was information gathering, where we looked across a broad range of use cases to identify gaps and needs. Phase 2 was taking that information and incorporating it into a web-based knowledge library that would be available, some of the resources and the tools that were already available, and make that kind of a one-stop shop for the industry. And then phase 3 was to identify specific products that we could develop in this project and develop those. And so as an output of this project, we've developed 11 standalone tools. There's a long list on the slide. I won't read it, but these individual standalone products have been incorporated into a comprehensive final report that will come out from TRB sometime next year. The project is ending next month, and so we hope that the report will be published sometime next year, and you can find all of these products as appendices to that report. And as Adam mentioned, we also have a the website that was created as phase 2, which is up, and there's a lot of different resources, and they're cross-referenced between some of the literature and other information that we found, and hopefully that is useful. So I'm going to turn it from here over to Ed Granzo. Ed was the the lead for the development of the LinkerAT tool and has very in-depth knowledge about the tool, and he's going to spend kind of most of the rest of the webinar talking about the tool. We are going to pause intermittently to allow for some poll questions and some short Q&A, and then hopefully we'll have about 10 minutes at the end, 10, 15 minutes at the end for questions. And Adam, I do think we have a couple initial poll questions before Ed gets into his presentation.
Yeah, Kelly, sounds good. Ed, I'm going to go ahead and let you start sharing from your screen while I bring up the poll questions here.
Sure. Let's see if I can do this.
So people should be seeing a question come up on their screen. We're just for the purposes of understanding who wants to use the tool and who can use the tool going forward, we're asking the question, what type of organization you represent? Go ahead and give a moment for everybody to answer here. The next one's going to be on your background as well. So a few answers still coming in, but Ed, we're seeing almost 50% state government, 30% consultants, and then the rest, about 5% on the rest of the areas there. And I'll go ahead and bring up the second poll now. Again, in the same vein, we want to know which of the following best describes your role within your organization. As the answers are coming in, Ed and Kelly, it looks like a technical data analyst is half of all respondents. Next would be project leader, program manager, or researcher, and then executive and other is the least amount. Yep, technical data analyst is definitely 50%, with program manager at a quarter of the answers. I'll go ahead and end the poll there. And Ed, I'll let you share.
Okay. Hold on. What I may do, Adam, it kind of went away, is just ask you to go ahead and keep driving the slideshow, because I have to reset this whole thing in order to make it work.
I'd be happy to. Here
Sure.
we go.
And can you, let's see, how do I get to your screen? Well, I'll do it this way. So basically what we're going to try and do is give you a little bit of background on how we came about building the LinkerAT product, what the LinkerAT product does, something of how it does it. And then I'll be looking at giving you a little more information about the operational aspects of it, basically trying to go ahead and give you enough information to decide whether this product and this tool is appropriate for your purposes. Next slide. Why are we talking about LinkerAT? Well, Kelly mentioned that this is part of the NCHRP project. Part of that project was to look at initially an analysis of needs in planning data and so forth for operations and planning, and go ahead and try and define products that would serve that need. We received a request from the panel to look specifically at the question of how to better link the ARNOLD data, which is essentially, as you all know, the FHWA reporting system for detailed mapping of road characteristics, and then the sensor data repository of the traffic message channel, which is based on INRIX data that is also an FHWA product. And that was what our aim was. So what we did is we looked at how this had been done in the past, and the determination was, in essence, that it had been done from the standpoint of using pure geographic conflation, and it also been done with geographic conflation utilizing an idea of the departure angles associated with links in the system to try and refine that process. What we did is we took those two things and then we combined that with an additional model which looks at information semantically about how roots in the thing are described. And I'll be talking about how that all works. Next slide, please. So what is LinkerAT exactly? LinkerAT is a Windows-based JavaScript application using the Microsoft web browser Edge as a front end and a user interface. And the use of Edge is predicated on the requirement that what we're doing is we're using certain add-in and COM components in Windows that require a certain kind of platform. This doesn't work with other browsers. And what it is essentially it's going to compare the two map networks, the ARNOLD and the TMC network, and it's going to try and establish cross references between those two networks. It's completely open source. Everything in it is a public product, and basically we will be distributing the actual software source code in JavaScript. It uses some libraries, and those are also included with it. And it is a new approach to addressing network conflation and cross-indexing, and we'll be talking about why that's advantageous. Next slide, please. Adam? Okay. What does LinkerAT do? What it basically does is it starts with a source and a target network, and then uses the information about geographic and semantic conditions on links in those systems to generate cross references. Built into LinkerAT because of the semantic element and because of some other issues is information about how each US state codes the information that they use in the primarily in the ARNOLD network, because the TMC network is the same across the entire United States. What it does is it looks at this information, and while it's doing this, it looks at the errors and anomalies in the coding and attempts to correct those things or provide information about the problems it runs into. And the idea is to move forward with completing cross-referencing for the entire map. Next slide, please. What we're going to try and impart today in the webinar is basically what is the methodology that is driving this in a little more detail, what is required in terms of files and steps to generate inputs and run the program, look at settings and parameters that allow you to customize how LinkerAT does its work. What are the actual software components that we're talking about in addition to the JavaScript code itself, the input-output datasets and reports, and also looking at some stuff where LinkerAT actually generates information that's placed in the geographic files. Folder tree structure and so forth is all tied to what it's going to take to develop state handlers for specific states. And I'm going to go into that in a little bit of detail because that's a very important part of how it's going to be implemented. And then how LinkerAT reports problems and how you can utilize that information. Next slide, please. So what we have is we have a couple of things. We have the browser-based application, which we talked about a fair amount, using Edge. And then we have the entire thing of using open software and open data standards to make sure that we don't have to have vendor libraries or vendor software involved in this. Along with this, we've developed documentation and deployment guide, which basically talks a lot about the things I'm going to talk about today, and then goes into much more detail and so forth in terms of looking at how you would customize it on a state-specific basis. Next slide, please. So I'm going to talk about the methodology that LinkerAT uses. Basically, this is a diagram which shows essentially what happens. What occurs is initially we utilize the combination of geographic proximity and angles to determine what link we want to assume is the corresponding start link in the Arnold network to the TMC network. Then what we do is we utilize that information plus semantic information to identify the end link of the same TMC link. Now, the important thing about this is that what we're doing is we're using semantics, but we're not trying to compare identifiers across the two networks. We're only looking at the coding within a single network. And then basically that same information is used using the combination of angles and proximity of node connections to generate a chain of links, which will represent the corresponding link in the TMC. Next slide. There are two advantages, at least two advantages to this approach. One is it's a very strong filter. It's fairly difficult for the software to generate a wrong route because of the conditions that are being asked for. And the second one is it allows the solution to develop incrementally. So each route is an independent product, which means that when you change parameters, when you change information that's being used to make these comparisons, it's localized to that particular thing. What this does is creates the ability to use an iterative and incremental process to build up your cross references. Next slide, please.
Hey, Ed, I'm just going to take a quick
Oh,
pause.
sorry. Oh, we have a poll.
Really...
I forgot. Yeah. Sorry about
no
that.
worries. This is a lot of good information, but we wanted to take a pause every now and then to just do a quick knowledge check question, just to make sure that we got some key points across effectively. So with that, Adam, I think you've just brought up our first poll question that is a little quiz. What browser can be used to make use of the LinkerAT tool? Is it Google Chrome, Microsoft Edge, Mozilla Firefox, or all of the above? So if you guys could go ahead and choose the one you think is most effective and look. Oh my God, I'm impressed. Everyone was paying attention. When we did a dry run for this webinar, I did not get this question correct. So it's great to see, yes, Microsoft Edge is the browser that you would use to make use of the LinkerAT tool. We have not built out the functionality in Chrome or Firefox. If that's something that's needed, it's something that would go into the implementation plan for this NCHRP. And we'll see what we can proceed with. Before we continue on, let me do a quick question. So far, are there any questions that folks have? Feel free to ask them through the chat, raise your hand, or go through the Q&A. So we'll pause for a minute to see if anyone wants to ask a question. And Adam, I think we might be able to unmute the person if you would prefer to ask as a audio versus through the chat. So let's pause for a second and see if there's any questions. Adam, I don't know that from my end, I don't see any questions. Do you see anything on your side?
Nope, not yet. If anybody has a question throughout, please feel free to raise your hand and then I will unmute you.
Okay. All right. Well, with that, let's go ahead and continue. Ed, back to you.
All right. Hold on. Okay. So what I want to talk about really briefly is how LinkerAT is put together and what the components of the software are. So basically what we have is we have the JavaScript program and routines, and that's the LinkerAT functions themselves, which call all the other aspects of the process. Component level interfaces, which is what we use to go ahead and do file reading and writing and other sort of system activities. I didn't mention this directly, but LinkerAT runs as a local application on a PC. This doesn't run as a web process or anything else. Then we also have the ActiveX port, which again is the same process of utilizing outside information. These call what is the turf geofunction library, which is one of those open source components that's available as public domain software. And basically what that does is that does the combination of managing the geographic database information and then also mapping the relationships between links in the two networks and so forth in terms of geographic location and the like. We're also using Microsoft PowerShell, which is how we launch the batch process. The LinkerAT, the actual process of finding routes and so forth, runs as a computer batch, sort of in background. And that also creates the ability to generate real-time reporting displays related to this. The Microsoft Edge browser, which we talked about, includes the editors, the ability to launch the batch process, and handling basically how information is stored and displayed in LinkerAT. Next slide, please. This one is a little small, and there's some larger copies of this that we'll briefly refer to. Basically, what this is this is what LinkerAT looks like in the Microsoft Edge browser. So the very top, you'll see some small buttons there. Adam, could you click on the top LinkerAT commands line there? And what this is basically the actual commands that run LinkerAT. The idea is basically here to go ahead and have a set of ways to get into the batch and also to be able to load custom settings and so forth related to the program. And then, of course, just exiting the program. The two below, basically what they do is they control whether or not the real-time display is being used during the batch. Let's just try next slide because we're doing this a little different. Oh, yeah, just next slide, please. Okay. Basically, what this is how the AT data repository is structured. It has a project, which in this case is named ARNOLD RITIS. It has both a area, state, and then a sub area. So this can be done by counties or other breakdowns of the information. Then there's a model year in terms of what the data is coming from, and then directories where it stores the information about ARNOLD and RITIS. And the translation is that whatever information is entered on this input will be used as its expectations in terms of what the file folder structure is going to be. Next slide, please. I'm going to skip over this one right now, but basically this just describes, and the file names are all generated by the information you just saw. So this one just describes how that generation is done and all of the files involved. If there's any questions about this, or if you want to talk about this, we can return to this after the main presentation. Next slide, please. So what we have is a set of geographic spatial parameters that control how the geography is used to go ahead and identify what links are matching. And again, this is something that we could talk about at some length, but we're going to hold off on that. And we're starting to get a little bit in the weeds here. So next slide, please. This is one I want to stop for a moment and basically talk about the idea that there is a line down here, remember previous visits. And what that is the step which controls whether or not the routes which have already been identified and saved are going to be reused or not. There's also a step where you're redefining the semantic identifier that goes in, which says reload quarter ID. and that uses the state handlers, and that depends on whether or not, again, you want to reuse the information that's already been generated. Next slide, please. So basically what we're using a format called GeoJSON. And the GeoJSON is it's a lightweight public standard. It's basically kept as text information when it's been serialized, and loads itself directly into JavaScript objects in when you're utilizing computer memory. So why have we chosen GeoJSON as a platform? It's completely customizable. It'll accept any kind of definitions of additional fields you need. It's built on the text line storage model. It's very, very easy to bring the serialized data in and then to push the object information out to a new serialized file. And there is no vendor dependency or anything else in terms of the product. There are freeware tools available for editing and management with the GeoJSON that supplement LinkerAT.
Hey, Ed.
Yep. Yep.
Jump in one more second. There are two questions that are being asked. I'm going to ask them to you. And then I think we have a pause for the next knowledge check question after that. So
Correct.
First one is, can LinkerAT be used to support, for example, the INRIX XD segment conversion with, with this rather than, the one that we talked about?
Potentially, yes. The geography portion of LinkerAT is very portable. The only requirement being that it be in GeoJSON format. The act that you're going to utilize the semantic identifier depends on the semantic qualities of the data set that you're applying. So basically, what you would need is you would need a specialized custom handler. We're going to talk a little bit more about that before the end here to do that. So
Yes.
hopefully that answers the question.
Yeah, so it looks like it's possible, but you might have to do a little bit more to support that. And then
Correct.
This is a question more for Kelly. Will the PowerPoint be available for participants? I'm not sure, but we'll get you an answer to that. A lot of the information is already available through the website, so I think that's a great starting point. And then a question from Israel Lopez. What data dictionary did you choose to use? Was it the TMDD Workzone Data Exchange? I don't know if that's relevant to this, but I'll let you answer, Ed.
Yeah, basically we utilized just and I've got a little more on this too. We utilized the basic information that comes from TSIA. We're utilizing the information out of RITIS in terms of the network information for the TMC side. And the ARNOLD files that we used were the ones that are actually on the FHWA website. So hopefully that answers the question.
Okay, so it was mainly the data dictionary that may be associated with the RITIS tool or through the ARNOLD tool. So the
Correct. Yeah. Yeah.
May not be necessarily as relevant. So the question that was asked on LinkerAT, the knowledge check question, or more, what was your level of familiarity with GeoJSON? And the answer, as you see, 41%, so almost half are aware of it but have never worked with it. Only 20% are very familiar with GeoJSON, and 30% have had some exposure to it. So as you sort of explained what GeoJSON is, are there any sort of follow-up questions for Ed in terms of familiarity and use of the GeoJSON format for the LinkerAT inputs?
What was that now? I'm sorry.
Yeah, no. I'm just asking the audience.
Right.
as far as the GeoJSON and why, you know, that's the format being used. All right. Not seeing any more questions. Let's go ahead and continue with the information sharing. Back to you, Ed.
Okay. All right. So next slide, please. So I'm gonna go through these very, very quickly, and we can certainly return to this if there's an interest. What I want to do is give an idea of how the data is actually being processed, and also show you a little bit about what the data looks like. So what we have here is basically the starting point is a GeoJSON file describing the network that we're interested in. What happens is LinkerAT makes its additions to that file in terms of indexing, bounding boxes, and things like that. And then that can be saved as a file in an intermediate state. And then, of course, you run the root finding process and so forth. And then what you end up with there is the output file with the GeoJSON, which can then be used as an input to the whole cycle once more. Next slide, please. So we have the same thing on the ARNOLD side, exactly in terms of processing. The information that is being saved in the output on the TMC side is mainly which TMC links have been resolved in terms of routes. And then we have the target inputs on ARNOLD. This is just based on the ARNOLD description as published by FHWA. Next slide, please. So overall, what we do, and this is better if you're actually running the program, but what's going to happen is that it's going to go ahead and put in the information into the screens and Edge. It's going to show you the settings that you've chosen. Also, you may have files that are needed to handle the actual information state, the data coming in from the state and in support of the state handler, and that is read directly. Then basically we're going to run through the process of, first of all, reading any information that was saved regarding references and cross-references from a previous run, updating the quarter ID, which is the value which is used to match the networks, and then going through a series of steps, which essentially will result in terms of number one, looking at one-way topology and flow direction, which provides information. Basically, sometimes you'll have situations where the links are coded in the opposite direction of the direction of travel, and there is an optional step in LinkerAT which will allow you to get that reported, and then you can check that information and see how well it's working. And then what you're going to do is go through, build the target links, and have an opportunity to examine what kind of problems have come up with your run. Next slide, please. So again, going very shortly, this information is displayed in real time when you're running the batch. Basically, this will give you a way to go in later on and find out what kind of problems have occurred. And the information includes things like where there's a partial route, where the route stopped, if it tried to find a start link to match a link, it couldn't find it, and so forth and so on. So, and again, this is something that could be talked about at greater length. Next slide, please. And now I'm going to talk real briefly, very briefly, about how the program itself is organized in terms of disk storage. The main thing I want to focus on here is the state handlers and the elements of the state handlers. So right now, we're using state handlers that were developed for Colorado. There's a check two-way flow, a check angles. We, of course, have to fill the quarter ID, which is being used for semantic comparisons, getting specialized state files, and then whatever global variables are needed. Now, these are all incorporated into a framework which essentially utilizes very, very small pieces of code specifically to each state, stored on the basis of these functions. And so the state handler process of getting it into LinkerAT has been automated with a batch script that combines all that information together and provides it. Next slide, please. So specifically with state handlers, what it's doing is driving a combination of the comparison model in terms of looking at identifiers, and then also looking at how direction is being defined again by the identifiers in the ARNOLD fields. And what it is essentially it's a step that says, if I am Colorado, do these things. They are stored, as I said, as scripts with command files, and doesn't require that there be a state-specific version of LinkerAT. LinkerAT will work for all states if it's coded this way. So these have to be developed, and what it requires is some understanding of JavaScript, and then also how you go ahead and might want to add additional attributes to the JSON in ARNOLD. So this would assist you in in making sure that the root finding process worked correctly. Next slide, please. Very, very, very briefly, the stuff on the left-hand side represents the actual JavaScript code that is being used in the check angle script. This is the type of process you would probably go through for any state, but this is the type of information and the things that have to be done in order to apply LinkerAT to a new state. Next slide, please. In terms of workflow, what's going to happen is the maps have to be obtained from the sources, which includes the RITIS organization and then also FHWA or the state. And then converting the maps to GeoJSON. These typically don't come as GeoJSON. You have to have the state handler built and functioning. You probably want to check your topology and flow using the option. You're going to make an initial run, and then you're going to revise and rerun that, hopefully refining the results. So maybe 2 or 3 runs even, basically by correcting attributes. There's some functionality to have alternative IDs in it so that you can take the information that was originally coded by the state and make it compatible with the LinkerAT process. Next slide. So what we've done is basically to date, we've looked at the workable product, demonstrated Colorado DOT using their infrastructure, which revealed a lot of issues related to dealing with Microsoft and IT security issues, which have now been pretty much taken care of. We started a pilot at Arkansas DOT to do the same thing. Custom state handlers for both of those are written. And then to look at some work with the third-party tools, map viewers, etc., in terms of how they can be used in the diagnosis of issues. Next slide, please. Yeah.
Ed, before we proceed to the next slide, a couple of questions.
Yeah.
In terms of your implementation with Colorado and Arkansas DOT, how much of a level of effort was it to do the pilot implementations? You know, how large were the networks? If you could elaborate a little more on, you know, what you expect, you know, say another state wants to try to use LinkerAT, what sort of resource and time might be needed in terms of conducting this use of the tool?
Right. Well, the Colorado, both Colorado and Arkansas are full scale. It's the entire state network is what we're using as a basis. I also did some work with Pueblo County in Colorado separately, just to test the sub area functionality. But the main thing was to do it statewide. The work involved in terms of generating the initial run really does come down to the state handler. And then, of course, there are some preliminary steps in terms of moving the data from the format that it's received into GeoJSON. But the tool does a very good job of that, and we didn't have any issue with that at all. So the state handler is the main thing. Probably to get that code running, something like maybe 2-person weeks. It's going to vary tremendously by the state because the coding systems are quite diverse in terms of looking at things. So, yeah, that answer the question?
It did. Thank you so much, Ed. Please continue.
Okay. Yeah. All right. So we got one more slide, I think. Next slide, please. Okay. So where does it go from here, I guess, is a question. And one of the things is this project is ending, the NCHRP project is ending, and that in the long run, a combination of packaging and distribution of the software, I'm pretty sure I made some mistakes along the way. And the scripts may find, there may be places in the scripts where corrections are going to be needed. And those would be found by probably a user working with it. And then somebody would have to go in and update that information. And then the whole thing of the state handlers creates an integration and contributed code where if you want to have an update release, which serves everybody, somebody has to be in charge of acting as a clearinghouse. And then, of course, there's the user support issue. As this goes on, if it gets more widely used, then there's a likelihood that people are going to run into problems where they're going to need direct support in terms of somebody helping them with the process. And who could do this? Probably industry societies and group, TRB committees, et cetera, federal agencies and research centers and projects related to this type of thing. One example would probably be the CAT Center at University of Maryland. And then, of course, colleges and universities could directly support some of this. Next slide, please. Thank you very much for your time. We had a few issues with the presentation handling and so forth and so on, but I hope that I got most of this across. I will say that as far as I know, in all likelihood, this PowerPoint will be available. It'll probably end up on the NOCO website. So I'm going to open the floor now for questions and discussions of what's been said. But again, thank you for your time. Feel free to contact me directly if you have any particular questions. Thank you.
Thank you, Ed. I'm going to go ahead and read a couple of questions that have come up, and then, feel free to ask the questions using the chat or Q&A. So the one question by Lauren Gang is, could the tool conflate other DOT road networks such as HPMS?
We have sort of started to look into that, and I would say yes. Generally, the process of the semantic processing of the data, what it's doing is it's relying upon the links on a route having a common identifier or having a combination of attributes in the file that can be used to generate a common identifier. Most networks are going to comply with that. One step in the process for Colorado was we actually had to go from a coded identifier, which included information about the particular link in the system, to an identifier, which in essence was the street or route name. And that solved the problem of the route definition. But the rest of it, the geography is pretty much portable across almost any map network you want to look at. The work that was done before this, not using semantics, but using a combination of angles and proximity, was actually done on the OpenStreetMap network, which is another parallel network similar to Arnold. So my short answer would be yes, but it probably needs a little bit of examination to make sure that it's a feasible process.
Okay, thank you, Adam. Another question from Pete, and I'm not going to say this last name correct, but Tone. How much time was required to run and finish the statewide Colorado conflation? And how much review was required when complete? And he says, very cool, thank you.
Well, thank you. It's yeah, it basically, we did not complete all the cross-referencing in Colorado because we ran out of time in the pilot implementation. And something I didn't go into at great length is that the reporting, what it does is it shows you what I call them exceptions, and there are classes of problems that occur. So you have a possibility that you can't find start links and so forth and so on. And you get a summary of how many of each of these problems have occurred. Some of it has to do with circular routes on links. The most common one is missing intermediate links. The program itself has been cleaned up quite a bit, and it now, to run Colorado, it takes about, I think it's an hour and a half, which is much better than it was when it started on a kind of a standard laptop environment. So it's not overly consumptive of resources, but it does take a little while. And then as you refine your processing and you have more and more visits available to reuse, then you're going to cut down on the amount of computation required. One thing I might add is one thing that helps a lot is it looks at the reverse direction of the link you've coded. So in the Arnold network, many links are topologically, of course, they have a direction, but they're a two-way flow links. So what happens is that LinkerAT will try and start at the end and go back to the beginning just by following the link chain and see if it can meet the criteria for that. So that speeds up the process quite a bit. I hope that answers the question.
I think you did. Thank you so much. Any other questions? If not, we wanted to spend 2 minutes, turn it over to Adam to show the NCHRP 08119 website and how to get to not only the LinkerAT tool, but some of the other resources available through this site. So Adam, let me go ahead and turn it over to you. And in the interim, if anyone has additional questions, feel free to put them in the chat. So over to you, Adam.
All right, Vishali, thank you. So yeah, this is I'll go start at the start of the tool. I'll go back to the NOCO website real quick to show everybody how they can get to the tool. So if you go to the NOCO website and you go on under Knowledge Center, the second one down is the data resources for planning and ops here. This brings you to a separate tool. Please note that for now, these resources are not searchable within our own Knowledge Center. We created this, this second one was created as part of the NCHRP project to allow for sort of immediate integration and the ability to match it to the products that have been described. There's a search area to look for the products around specific data application areas. These application areas relate, as you've seen, to some of the to the webinars that have been happening over the last few weeks, and will continue into next week. Next week is on freight data needs, and many of these areas yield specific research products that were developed by Kelly and the AE team, and then as well as additional resources that are out there within that specific topic area. So lots of good stuff in here for those who are looking for these data uses. And then if you go to the actual research product list itself, this brings together all the various research products. You can see the LinkerAT tool in here. And a few other specific products that were developed. Kelly and the team presented on this in last week's webinar, use of ways for data and operations planning. So quite a few things in here based on the research that was done as part of this project. And then some additional resource areas as well that are in there. The hope is to continue to update this, so you'll see it change, and if items are needed to be added, they can be added in. If you have your own resources that you think correlate to this, please be sure to share them with us. You can email me or email the contact line at the center to do that as well. And again, encourage everybody to take a look at this and pin it to your bookmark toolbar as a place to go when you're looking for information on this topic area.
Excellent.
Adam, hey, Kelly, this is Kelly. Just a quick note that none of the products are available in full yet. They still have to go through the TRB publication process. The website describes the products, and you can find out more information on the webinars that we've showcased some of the products. But we're hope that when the report gets published, that all of the products are available in that report, and we would also be able to release the tool at that point.
Very good clarification, Kelly. Thank you. Any other questions regarding the LinkerAT tool? And then Adam, if you could just show where the previous webinar recordings are one last time. So for those that want to see this webinar and process some of the more detailed information, there you go. YouTube/C/NOCO. So Kelly or Ed, any last parting words?
No, I'd like to thank everybody for their attendance.
Okay, and then the next webinar is taking place next week. Is that right, Kelly and Adam? So be sure, if you're interested in, let me see, let's go back.
Yep, it's going to be on
data management.
There we go. Freight data management, December 12th, 1 to 2:30 p.m. All right. Thank you everyone for joining today. And you get 5 minutes back off of your hour. Have a great one.
Thank you.
Thanks everyone. Bye.